Hello, this is Mr. Prosky speaking. Hope you guys are all having a good day. This is our first lesson of the year in geometry. This is 1.1. The name of this lesson is Identify Points, Lines, and Planes. Our essential question is, how do we identify points, lines, and planes? This whole chapter is just kind of an introductory unit on basic geometric shapes and figures, terminology, and stuff like that. There are a lot of different definitions in this chapter, so just stay with, in this lesson especially, so just stay with me and do the best you can. I will usually try to do a warm-up for every lesson, and in this warm-up we have various shapes here, and I'm asking you to go ahead and match the corresponding shape with the word that defines it. So if you think, for example, number 5 is a square, if you think letter C is a square, you're going to put C for number 5. So go ahead and pause the video and see if you can do it. Okay, welcome back. So for this section here, first thing we have is the lines. Which one looks like a line on here? It's kind of hard to tell, but the ones that look like lines to me are E and G. The difference between E and G is that E has dots and G has arrows. So this is actually the first two are line and line segments. A line actually goes on forever, so then we're going to put G for line, and then line segment's going to be E. Those dots mean that the line ends there. Basically, it's a segment of the line. Okay? Which of these, I'll cross them off that we're done with these. It's a good bit of practice. Which of these looks like a circle to you? Hopefully you said C. C is the circle. Very good. How about the triangle? Which one's a triangle? H is the triangle. Square? What makes something a square? There's actually something very specific that makes something a square. Hopefully we can see that A is going to be a square. A square is both a rhombus and a rectangle. A rhombus means that all the sides are congruent, and a rectangle means that all the angles are congruent. So a square is both a rectangle and a rhombus, and A in this case is going to be the square. Which one's going to be the rectangle? Hopefully you said D. As I said, a rectangle has 4 congruent angles. It's a quadrilateral with 4 sides. And you can see these are all 90-degree angles, which means it is a rectangle. Which of these is an angle here? Let's cross these off. Which one's an angle? We have angle and right angle left. Well, F is actually an angle. What makes something a right angle? Well, what makes something a right angle is going to be a 90-degree angle there, or a perpendicular kind of thing going on there, which means B is going to be the right angle. Okay, let's get into the definitions here. Feel free to pause the video if you need to. There's a lot going on here. We're going to draw some different we're going to draw some stuff in over to the right here in this kind of box to kind of help us with all this stuff. So I know this is a lot to deal with. It just is kind of what it is, and it is important, but it's a lot, and I recognize that. So an undefined term is a word without a word what? A word without a formal definition. Some undefined terms include points. Include what? Points, lines, what? And planes. Points, lines, and planes. Those are basically things that we kind of know what they are, but a formal definition needs to include other terms in it, and it's like these are so basic that there's not really like a place. We need a place to start, basically. These are the starting point. These are what are called like kind of like axioms, or things that we just assume to be true. And it's kind of hard to define it. Usually a formal definition needs to use other terms in it, and we can't use any more basic terms than these, okay? But a point is literally just a dot. So here we have this dot with A. We can call this point A, or we can literally just use the letter A. I'm going to put a circle around it. That's the preferred way to do that here is just A. All right? A point has no dimension and is represented by a dot. No what? No dimension and is represented by a dot. Okay? A line has one dimension, which means it goes left and right or up or down. It goes, you know, it has like one back and forth motion that it can go. And it's represented by a line with 2 arrowheads because it goes on forever in both directions. If you recall, we talked about a line segment, and a line segment did not go on forever in both directions. Okay? It stopped. All right, and then through any 2 points, there's exactly 1 line. How many lines? 1. And you can name a line with any 2 points on the line or by a single letter. I'm gonna put single letter around here because that's helpful as well. Okay? And then I'm gonna write down here, kind of important, a line equals 2 points. And I'll put a star by that. All right, we're gonna draw a line over to the right over here. So I'm gonna draw line AB. So I'm gonna draw 2 points. And I'm gonna go like this. Like, it did not look good, so I'm gonna fix that. Okay, so there's point A and point B. The line connects and goes through both points. So what are some ways we can name this? We need 2 points, so we can do AB, and we put a line segment on top with double arrows because it goes on forever. How else can we rename AB another way? Well, yeah, we could also, if B were different in a different spot, or however we want to do it, we can call it BA as well. Also, you may see a single letter on the, like, by the arrowhead of a line. You could also call this, like, there's line L. There's an L over there by the line. Okay? You guys are doing great. Let's keep going. All right, a plane has 2 dimensions. It can go back and forth. It can go, 2 dimensions is like a coordinate plane. It can go left and right or up or down. It goes like in 4 different directions, basically. 1 dimension means it goes in 2 different directions, okay? All right, a plane has 2 dimensions and is represented by a shape that looks like a wall, or the floor, by a what? A wall or the floor, but extends without end. Okay, so let's fill in these here. Through any 3 points not on the same line, there's exactly 1 plane. So that's kind of important. It's not just 3 points, it's 3 points that are not in the same line will make a plane. Okay? You can name a plane with any 3 points not on the same line or by a single letter. And we're going to put down here, we're going to put plane equals 3 points. And I'll put a star by that as well. Okay, 3 points for a plane. Now I'm going to draw over to the right over here. And like I said, feel free to pause the video if you like. Let's do this here. Sorry, give me 1 sec. Try to figure something out. All right, I think I figured out what I was trying to do here. So I'm going to try to pull out the ruler. You guys may not see this, but we will see how this goes. All right, we're going to try this. Not great. Let's try that again. There's that. I have to use a ruler in this app, which is a little bit funky and something I'm not exactly used to. May have to avoid that in the future, but it's okay for now. Okay, here's a plane. It's meant to be a quadrilateral, and it kind of gives us the idea. So, plane is basically like, it's kind of like, think of a piece of paper. So we can, if we have 3 points, 3 points, remember they have to not be in a straight line, so we have E, G, and F, or we can put an M in the corner here. So this is all, we could call this plane M. or plane EFG. Okay? All right. So we got line, we have planes. Okay, let's talk about collinear and coplanar points now. So collinear points are lines that lie on the same line. On the what? Same line. So if we draw a line like this, it's not going to be perfect, but it'll get the job done. We have 3 points. A, B, C, and then we have D up here. The lines that are collinear are which ones? Well, A, B, and C are on the line, but not D. Those are not. So A, B, and C are collinear, and D is not. Coplanar is similar. It's going to be points that lie in the same plane. On the what? Same plane. So if we draw, I'm just going to sketch it this time here. So if we have E, F, and G, and H is down here, it would be E, F, and G, but not H. Okay? All right, moving on here. Let's switch up the colors here. Keep moving along. Let's see, I'll do that, and we'll do green. Okay, so we're on pink now. Okay, a defined term is a term that can be described using known words. Using what? Known words. We kind of talked about that already, right? We talked about how the undefined terms you can't really use any other words to describe them, so they're kind of like the most basic ones. But defined terms are using known words. All right, a line segment and endpoints. It's part of a line that consists of 2 points called endpoints. Called what? And all points on the line between the endpoints. Line segments do not go on forever, and line segments can be on lines. Okay? And we're just going to put part of a line down here. That's what a line segment is. Part of a line. Okay, so let's talk about this up here. So a line segment. So we'll draw a line segment here. We have 2 points, P and Q. And we'll also draw another line, actually a line that goes past these 2 points. This will be J and K. So we have line segment PQ and line segment JK. Okay, so those are different types of line segments. All right, draw a line right here. Okay, array is part of a line that consists of 1 endpoint. How many endpoints? And extends forever in the opposite direction. In the what? Opposite direction of the endpoint. And it says be careful of labels. The endpoint always comes first. So for example, we're going to draw an array here. So we're going to draw 2 points. It's basically kind of like half of a line, basically. It's going to go past, it's going to go one direction forever, and then it's going to stay. It's going to start at C, and it's going to go past D forever, but it's going to stop at C. Okay? So, for example, it says the endpoint always comes first. So what we can say here is that CD, this is how you would write it. You always want to draw the arrow going to the right with the endpoint first. Is not the same thing as DC. That's not drawn well. DC is not the same thing as CD in this case, okay? The endpoint always comes first. All right. And arrays that are the same must overlap each other. Must overlap each other. All right. So CD, not DC. All right, sounds good. So opposite rays are 2 rays who share a common endpoint. Common what? Common endpoint and extend in opposite directions. And 2 opposite rays make up one line. Two opposite rays make up one line. So if we have an endpoint in the middle here and it goes past one direction this way and the other direction this way, we have M, N, and P. M, N, and P. Then we have opposite rays that are going to be NM. And what's the other one going to be? It's going to be NP. Okay, you always have to start with the endpoint. The endpoint goes in the middle. So we have one ray going this way and one ray going that way. And it makes a whole line. But basically, you always have to start with the endpoint. Even if it's kind of weird that M comes before N here, you start with the endpoint. Okay? All right. We are going to talking about intersections here. I don't like this definition here. Intersection, all we need to say for that, it is where shapes overlap or cross. Or shapes overlap or cross. Okay? The intersection of two lines, if you think about where two lines intersect, so let's draw that real quick. Here's two lines, right? It's just kind of a rough drawing. What's this right here where they overlap? What is that? That is a point. The intersection of two planes, we're not going to talk about drawing two planes right now, but the intersection of two planes is going to be a line. And we'll talk about visualizing that a little bit more later. And the intersection of a line and a plane is a point. All right, moving on. So we're going to do one example together, then you guys are going to try a few on your own. That's how I like to do these kind of problems here, is give you practice. So the first one we're going to do together is give two other names for, what's this line right, what's this what's this notation right here? It says LN with a double arrow on top of it. That is line LN, okay? So line LN, we need two other names for LN. So LN is this line right here. And if we recall, how many points do we need to name a line? Well, we need 2 points to name a line, or else we can look at the, do you see a letter that's like on right by the corner of the line? Well, I see there's a B right here, so we can call it line B. You can always just call it by that little letter right there. Or we could rename it. We have L, M, and N. We have those 3 points on the line. So what do we think? What do we want to call this? Well, I can rearrange NL and flip it around. I could also use, instead of using N and L, there's also M in there. I could also do LM. Remember, you use a double arrow to show it goes on forever in both directions. So those are some other examples of things you could do for line LN. Next thing it says give another name for plane Z. Plane Z. So here's the Z in the corner. So how many points do we need to name a plane? Well, if you recall, we need 3 points to name a plane, and also those points need to not be in a straight line. So we need any 3 points that are on the plane. I'll point out right here that Q is floating above the plane. It's kind of coming out at like an angle, and A is just the name of this line right here. So this one's actually not, so kind of ignore that one, but what do we think? What are some 3 points that are not on plane Z? Or that are not in a straight line, I'm sorry. Yeah, so we could call it plane, let's see here, LMP. We could also do plane MNP. Okay, those are 3 points that are in the plane, but that are not in a straight line. So any variation of those points would work. All right, it's your turn. Why don't you guys go ahead and try C through F, see if you can figure it out, and then we'll go through some in a second. All right, we need 3 points that are collinear. What does collinear mean? Well, collinear means in a straight line. So what 3 points are in a straight line? Well, I see L, M, and N. All right, now we need 4 points that are coplanar. We need 4 points that are in the same plane. You should have gotten L, M, N, and P. Those are all in the same plane. Well, they're on that piece of paper, that quadrilateral right there. We need 2 other names for line MQ. This is line MQ right here. Okay, so MQ, we can flip it around and call it QM with the double arrow. We could also, this A down here, remember, labels the line 2. We could also call it line A. So A is not a point, Z is not a point, though, and B are not points. They are basically just labels for the line or plane. And then it says name a point that is not coplanar with lines L, N, and P. Okay. Which point is floating above or below the plane? Hopefully you said Q was floating above or below the plane, because that is correct. All right, sounds good. Let us keep moving along here. All right, example 2. It says choose your own adventure, pick 4 problems to do. Yeah, there's A through F here. So if you'd like to pause the video and give them a try, why don't you give it a try? Otherwise, we're going to go over it in a second. Alrighty, let us talk about this. Let's give another line for what is this symbol right here? It's got VX with it's got a line above it with no arrows. That's a line segment. So we need another name for line segment VX. So the other one you should have done for this one should have been XV with a just line with no arrows above it to show it stops. All raised with endpoint W. So I have W, W goes to X, W goes to Z, W goes to V, and W goes to Y. So we have WX, and we do the ray symbol. We have WZ, the ray symbol. WV with the ray symbol, and we have WY. Apologize for the bad writing. And then name any pairs of opposite rays. Opposite rays share an endpoint in the middle, and they go in opposite directions. So WX and WV go in opposite directions. They start in the middle and go this way and that way. And then also WY and WZ go in opposite directions. Those are kind of hard to see, so if you have more questions about that, make sure you talk to me in class. All right, give another name for segment YW. Well, we can just flip around the symbols or the letters. We could do WY. Are VX and XV the same ray? So I'm going to give you an example of 2 rays that are the same. If we had VX, the same ray would also be, or the same ray is, yeah. So they have to go the same direction. So you would have to go like this if they were the same ray, basically. Okay? In this case, VX goes one direction and XV goes the opposite direction. So this one's going to be no. And then VW and VX, are those the same ray? They actually are because they overlap and go the same direction. So this one is going to be yes. All right, sounds good. Moving on. Sketching intersections of lines and planes. It says whenever sketching figures, always do them in pencil and use a straight edge. We use a dashed line, a what? A dashed line to represent something behind another thing. And using the sheets of paper will help you visualize the planes. So it says sketch a plane M and line W that intersect the plane at more than one point. So in class, I would hold up some paper and a pencil or some kind of writing utensil and try to show you, like, if they intersect at more than one point, how would that happen? In this case, I'm gonna sketch a rough plane here. The only way that plane M, if it's plane M, we're gonna just label it in the corner here. For that to happen, the line has to be in the plane like this. So this is going to be line W. It's basically on the piece of paper, and it's going to cross at more than one point. If the line is angled in any direction, let me use a different color here. If we had a line that was angled like up a little bit, it went through the paper like this, and this dashed part was behind, you can see. So imagine that this is, you can see this, and you can't see this, the dashed part. So imagine that line is going out the top of the paper and going through the bottom of the paper. You can see it'll cross at one point here. The only way for it to intersect the plane at more than one point means that it has to be, the line has to be on the plane exactly. Otherwise, it would be only touching at one point. Kind of hard to visualize. So make sure you stick with me here, okay? All right, sketch a plane M and line W that is in the plane. Can sketch another line E that intersects line W and plane M at a point P. So it's got a lot going on here. Let's first draw the plane. Okay, the planes are our starting point. I wish I could draw this better, but it's just the program's not letting me do that. So, all right, we have M here, and then We need a line W that's in the plane, so I'm going to draw a line that's in the plane. Okay. This is line W. I'm going to use a different color one here. And then we need a line E that intersects line W and plane P at or line and plane M at a point P. So we're going to draw, it's just going to intersect the plane at one point here, kind of like we were talking about. Can't see this dash part. And that's going to be line E. And it intersects at point P. And yeah, there we go. That's kind of our example there. I do apologize that it's a little sloppy. Make sure you come to see me during or outside of class to get more examples if this is confusing to you. It is hard to visualize without me being there to show it to you in person. All right, now we're going to talk about sketching the intersection of two planes. Okay? So let's do it here. We're going to do it two different ways. Okay? All right, so let's do it the first way. So the first thing that we want to do is we want to draw a tall rectangle. Basically, so we're trying to show where like two pieces of paper overlapping and kind of where they get across here, okay? So let's draw a tall rectangle. Let's do that. I'm going to do a different color for each step here, okay? Let me draw that better. There is a tall rectangle. Not perfect, but it'll work. Next thing we're going to do is we're going to draw two diagonal lines that intersect the sides of the rectangle, okay? So we're going to draw two diagonal lines like this. Then what we're going to do is we're going to connect the diagonal lines horizontally, okay? So we're going to draw, basically you're going to see here, it's like we're crossing. We're going to draw where these cross here. And then we're going to, we're actually going to draw in the middle here. This is where they intersect with a dashed line right here, okay? Actually, no, we're going to do a solid line. So we'll do a solid line like this. Okay, can I visualize it there? And then what we're going to do is we're going to erase. I'm not going to do it on here, but we're going to kind of, I'll draw little dash marks. But you would erase with your pencil kind of lines. This part right here that I'm drawing with little marks. That part is behind the vertical rectangle there. And you can kind of see that this part, well, I'm going to erase this part. You won't be able to see it. But the red, blue, and red on the left, bottom, and right, those you'll be able to see because they're not obscured or covered by the tall rectangle. But those other parts there, I would just erase some lines there so you can kind of see it. Erase all part of the lines that are behind is what we did. Behind. Okay? Now I'm going to give you another way to do it. This way is a little bit, I think it's a little bit easier here, okay? So, actually we're going to kind of ignore these, this example here. All we're going to do for this is we're going to draw two intersecting parallelograms. I'm going to draw one parallelogram. That was really bad. Let's try to draw it better. There's one parallelogram. Nope. You're not seeing any of this because I have to erase it and it won't show up on the program. Okay, there's one parallelogram. Now I'm going to kind of take this right one here and I'm going to go like this. So actually the intersection of the two planes, where they cross, is going to be this section right here. And then this is plane L and plane M. Okay, so either of these examples is easier to write. This would be plane L and this would be plane M. Okay, either of these would be fine. This is kind of, like I said, it's just hard to visualize. So make sure you pay attention during class or come get help if you need to, okay? All right, there are a couple examples for you to try down here. Give them a try, see how you do, and then we'll go through it. All right, it says sketch two different lines, X and Y, that intersect the plane P at different points. So we're going to draw a plane. And then we're going to draw two lines that intersect at different points. So I'm going to draw a line X, intersects here and goes through the bottom. There we have line X. And then line Y is going to cross right here and go through the bottom like that. And that is, yeah, those are two different lines that intersect at a different point. All right, next thing we're going to talk about, last thing for this section is name the intersection of line MX and line A. So here's line MX and here's line A. Where do they cross? Well, they cross right here, and that's point M. And it says name the intersection of plane C and plane D. Well, here's plane C and here's plane D. Where do these two planes cross? They cross right here, which is line A. And this is it for this lesson. That was a very long lesson. Probably going to be broken up into a few days in class, but thank you for watching. Make sure you finish your homework, come get help if you need to, and thanks for listening.